Well, I had a few requests for people wanting to see how this display dash works that connects to the OBD1 of the truck. So here's my monstrosity of circuit board. So basically this is our interface chip. It connects to a couple of the I/O. We'll go over to the computer and I'll show the rest of the circuit. There's also this guy here. You don't have to worry about this thing. This thing's just a temperature and humidity sensor. So I added an extra cell here, so it's doing a live reading of this guy here. See, if I hold it, temperature will go up. All right, off to the computer. Okay, let's have a quick look at the back of the display board. So basically I am taking a couple of signals from this connector, and from this connector a couple of wires, and then over here I'm grabbing the power and ground. This one has 5 volts as compared to this one, which has the 3.3 volts. Okay, at the heart of the, well, besides the cheap yellow display, at the heart of the circuit is just this one little IC. It's a buffer chip. And basically what this is going to do is we're going to change the voltage level of the ALDL trucks talking at 5 volts. The ESP32 talks at 3.3 volts. You can eventually destroy the ESP32 if you pump in the 5 volts. So basically what we're going to do is we're going to transmit out of the ESP32 into this pin, and the signal coming out will be of a different voltage coming out of there. We also need to enable the line, and that's where this pin comes in. It enables this output to work. And then in the reverse direction, same thing's got to happen. So the truck is going to respond with a signal. It's going to come into this buffer, come out here, and go into the ESP30. And once again, that gets enabled by this pin. The reason why there are these enables, especially for while talking to the truck, is we need to release the line. And that's where I come into a lot of problems with trying to use other circuits, was that they grab hold of the line and it doesn't release the signal. So when the truck is responding, the signal gets sourced to ground through these other circuits. And where this one, we can enable and disable the line by using these enable pins. That's where this comes in. The super simple, cheap, and easy fix. So here's another basic overview of the circuit, how it's connected to the truck ALD connector here. And then, so here's the buffer chip, and then the cheap yellow display. So as you can see, like over here, the 2 pins are in the center. So I'm using IO 11 and 12. Up here, I'm using 17 and 18. And then here's our power. So the buffer chip needs to get the 5 volts and ground. Then the ALD pin, it both transmits and receives over 1 wire. And that's where this buffer chip is really needed. So as you can see, we're going into pin 5 and pin 3. So here, when the ESP32 is transmitting, it will come into this chip. It gets an enable signal, and then it's able to send a transmission to the truck's ECM. Then it releases the line, and about 40 milliseconds later, a response comes back, which will be all of the data that you just requested. That's how the older ALDL worked, was you send a request for data, and then it responds with data. So the response will come into this buffer, gets changed from the 5 volts to 3.3 volts, comes out, and then goes into the ESP32. And like I said before, there's enable. So we enable the transmit, and then we release, and then we enable for receive, and then we release. and then it just keeps on doing that continuously. I think I'm grabbing like 5 or 10 requests from the computer per second. So the screen gets plenty of display. So here's the last image that I'm going to share. Here is the GPL display, the ESP32, that it can do a transmit, but it gets an output signal so that it can send the data out. It goes to the ALDL connector on the truck, which is also right here. On my truck, it is the baud rate is 8192. It's the M connector. Right above it is a ground. If we go back here, basically, yeah, so we got our ground, and then this would be the pin. After it sends its request, it releases the line so that the transmit can come back in, comes in here, we turn on the output so that we can start listening, and then it transmits into GPIO 17. One other thing, you don't need one of those fancy ALDL connectors. I bought one, and honestly, it was a waste of money. Just connect to this pin and ground. That's it. You could stick a wire into the connector or back probe the terminal. Whatever works for you, just don't forget the ground. Here is my GitHub on my ALDL digital DAD. Since we don't have the OBD2 port, I want access to the ECM and without having to use a computer, like a laptop in the other seat. So I came up with this, and this will step you through some of the basic features, some of the wiring on how to do this. Here, this is the model of display that I'm using. It's a 5-inch. Here's an Amazon link. You can go to AliExpress and buy them a little bit cheaper. This is the buffer chip, which is pictured right down here. You can also get that on Amazon or AliExpress. The basic wiring. I set a link for the little connectors, so right here, so that you could build your own. That's what I use. I use this kit here. Also, I use an RJ11 or the old phone jack right here, just so that when I take it in and out of the truck, I just have a quick, easy clip to undo. You could use whatever you want. But down here, I explained, that you have to use Arduino IDE. So I run you through the basic setup. In the boards manager, you have to search for ESP32, install the one by Espressif. Then you need in the library manager, search for LVGL. You have to install the 8.4 version, not the newest one. So you have to select this, look for the 8.4, and then install it. If you try and compile it, it'll give you all types of problems. Down here, next one would be the ESP32 display panel. That's also made by Espressif. You can have to install that. I think during the install, it asks you, do you want the dependencies? And say, yeah, you want those. Then we set up the board under Tools, Board, ESP32, then up here, ESP32S3, Dev module. Then you go back into the same area and you want these settings. The most important ones is flash size, PS RAM, set it to OPI PS RAM. This partition scheme, also select that. Then you can download the code, download the zip, unzip it into a folder. Must be named ALDL digital dash. Otherwise, once you try and open the INO file, Arduino IDE complains that it's not the right naming. And do you want the right name? You can then click the check mark to test compile it. So right up here also there's like that check mark. You can check that. It should compile fine. Connect your ESP32 at this time. Then you can go back into the tools port and select your board. I'm on Linux, and that's the way it looks in Linux. Then you're able to click the right arrow, which will also compile again and then upload to your display. You'll get a screen that looks like the very first picture. So here, it is connected to the truck, of course, so that it is getting data. I'm not moving, so I got no miles per gallon. The engine was just warming up. You can select each cell. You just touch it, and it will cycle through all the available choices and select yours the way you like. And that is it. Good luck, and hope you enjoy it. See ya.